Did you know the number of possible universes in the multiverse is estimated to be around 10⁻500? Based on the number of possible configurations of the curled-up dimensions, the concept of parallel universes has ancient roots, with Greek philosophers like Democritus proposing an infinite number of worlds. In the 16th century, Nicholas Copernicus' heliocentric model challenged Earth's centrality, paving the way for the idea of multiple realms. The 20th century witnessed a scientific surge, particularly when Hugh Everett formalized the many worlds interpretation of quantum mechanics. In the 1920s, physicist Max Tegmark proposed the concept of the multiverse to explain the strange behavior of quantum particles. Tegmark's theory suggests that every time a quantum particle makes a decision, it creates a new universe in which it made the opposite decision. This means that there may be an infinite number of parallel universes, each with a slightly different history. According to Tegmark's calculations, there is a 1 in 10⁻123 chance that you will run into your exact doppelganger in another universe. One of the earliest proponents of the multiverse concept was physicist Hugh Everett, who in 1957 proposed the many worlds interpretation of quantum mechanics. This theory suggests that every quantum event, such as the decay of a radioactive atom, creates a split in the universe, resulting in the formation of 2 or more new universes. The many worlds interpretation suggests that there are an infinite number of universes, each with its own unique history. This means that there is a universe out there where you're watching this video right now, but you are also a famous rock star, or a Nobel Prize-winning scientist, or even the President of the United States. Our universe could be just one bubble in an infinite cosmic foam, each bubble representing a separate universe with its own unique laws of physics. This mind-boggling idea, known as eternal inflation, suggests that the universe's expansion never truly ended, but continues to create an endless array of bubble universes. The rate of inflation during this period was incredibly rapid, with the universe doubling in size every 10⁻⁻35 seconds. Traveling at the speed of light, a journey across the observable universe would span approximately 46.5 billion years, highlighting the immense scale and cosmic grandeur that surrounds us. One of the most famous proponents of the multiverse theory is physicist Michio Kaku. In his book Parallel Worlds: A Journey Through the Multiverse, Kaku argues that the existence of parallel universes is not only possible but almost certain. He bases his argument on the vastness of the universe and the many different ways in which the laws of physics could have played out. The laws of physics that govern our universe, such as the laws of electromagnetism and gravity, appear to be finely tuned for the existence of life. This delicate balance raises the question of whether these laws are unique to our universe, or if they are merely one manifestation of a vast spectrum of physical laws across the multiverse. The observable universe spans a staggering 93 billion light-years in diameter. Within this cosmic expanse, astronomers estimate the presence of at least 100 billion galaxies, each hosting billions or even trillions of stars. With such mind-boggling numbers, the sheer scale of the universe raises the tantalizing possibility that it is not alone. There could be ample room for an infinite number of parallel universes. In the 20th century, the concept of parallel universes gained new scientific ground with the development of quantum mechanics. Quantum mechanics is a branch of physics that studies the behavior of matter at the atomic and subatomic level. It has been shown that at this level, particles can exist in multiple states simultaneously, a phenomenon known as superposition. This has led some physicists to suggest that there may be an infinite number of universes, each with a slightly different configuration of particles. The cosmic microwave background radiation, CMB, a faint afterglow permeating the universe, serves as a window into the early universe, a mere 380,000 years after the cataclysmic event known as the Big Bang. In 2003, scientists studying the CMB made a startling discovery that challenged conventional cosmological models. A peculiar pattern of cold spots, regions of unusually low temperature, scattered across the cosmic landscape. The CMB temperature is a mere 2.7 K or minus 270.45 degrees Celsius, a testament to the cooling of the universe since its fiery inception. CMB cold spots exhibit temperatures up to 70 μK or colder than the average CMB temperature, an anomaly that has puzzled scientists for decades. The statistical significance of these cold spots is extremely high, suggesting that they are not mere random fluctuations, but rather the result of some underlying physical process. Approximately 95% of the universe is composed of dark matter and dark energy, entities whose properties elude conventional detection. The pervasive influence of these mysterious components raises the possibility of interactions with parallel universes, offering an enigmatic connection between the known and the unknown. Shocking point is the total mass of dark matter in the universe is estimated to be about 10 carat 85 kilograms. This is about 10 times the mass of all the visible matter in the universe. String theory proposes the existence of multiple dimensions, forming a complex landscape beyond our familiar three-dimensional space. At the heart of string theory lies the concept of tiny, one-dimensional strings that vibrate at different frequencies, giving rise to the fundamental particles that make up our universe. String theory proposes the existence of 10 dimensions, with 7 of them curled up at incredibly small scales. The size of the curled up dimensions is estimated to be around the Planck length, the smallest possible length in the universe, approximately 1.6 x 10 carat minus 35 meters. The number of possible universes in the multiverse is estimated to be around 10 carat 500, based on the number of possible configurations of the curled-up dimensions. String theory is one of the most mathematically complex theories ever developed. The equations of string theory are incredibly complex, and physicists are still trying to fully understand them. The number of possible universes in the multiverse is estimated to be around 10 carat 500, based on the number of possible configurations of the curled-up dimensions. This unimaginable number suggests that our universe is just one of an infinite number of universes, each with its own unique physical laws and history. Reports of glitches in the matrix remain largely anecdotal, with no scientific studies providing concrete evidence. Studies suggest that approximately 40% of individuals claim to have experienced some form of déjà vu, a phenomenon often loosely associated with reported glitches. The prevalence of these experiences raises philosophical questions about the nature of reality, but it's important to note that these discussions are speculative rather than grounded in empirical data. On March 8, 2014, Malaysia Airlines Flight MH370 disappeared from radar, sparking a prolonged mystery. Despite extensive searches, the fate of the Boeing and its 239 occupants remains unknown. The official investigation suggested the plane deviated from its course and possibly entered a parallel universe. After 38 minutes of flight, it turned westward toward the Indian Ocean. Despite a vast search, no wreckage has been found. The idea of a parallel universe, though speculative and lacking evidence, has intrigued some theorists and enthusiasts. The Philadelphia experiment, an alleged naval undertaking in 1943, claimed to have teleported the U.S. Eldridge from the Philadelphia Naval Shipyard to Norfolk, Virginia. The alleged teleportation of the U.S. Eldridge took place on October 28, 1943, during a test of a new radar-based degaussing device. The ship's location reportedly shifted from the Philadelphia Naval Shipyard to Norfolk, Virginia, and back again in a matter of minutes. The crew members who were on board the U.S. Eldridge during the alleged teleportation reported experiencing a variety of strange phenomena, including disorientation, time travel, and even integration with the fabric of another universe. Many of the crew members reported feeling intense heat and pressure as if the ship were being squeezed into a small space. Some of the crew members said that they saw strange lights and geometric shapes swirling around the ship. Others reported feeling themselves being stretched and pulled apart as if they were being torn from the fabric of reality. The Philadelphia experiment remains shrouded in mystery and controversy. The Mandela effect is a widespread phenomenon where a large number of people collectively misremember specific events. For instance, a significant percentage of the population recalls Nelson Mandela dying in prison during the 1980s, despite historical records confirming his survival until 2013. Studies indicate that over 50% of the population is aware of at least one Mandela effect, reinforcing the notion that shared false memories might be more than mere coincidences. Déjà vu has been reported by an estimated 60 to 70% of individuals at least once in their lives, according to various surveys. Scientific explanations for déjà vu often involve the brain's processing of familiarity, with specific regions implicated in creating a sense of reliving a past experience. While déjà vu is a well-documented phenomenon, there is no empirical support for the notion that it stems from encounters with parallel universes or glitches in reality. While the existence of parallel universes remains unproven, scientists are continuing to explore the possibility using various methods. One approach is to look for subtle imprints that other universes may leave on our own, such as gravitational waves or exotic particles. Another approach is to study the behavior of black holes, which are thought to be gateways to other universes. The search for parallel universes is one of the most exciting and challenging frontiers in modern physics. While there is no guarantee that we will ever find definitive proof of their existence, the quest itself is helping us to better understand our own universe and the nature of reality itself.